A galaxy can hold as few as 100,000 stars or as many as 3,000 billion. Welcome back to the Anatomy of Everything. Last time, we went inside the birth of the universe itself. Today, we zoom into the structures the universe used to organize all of that material. Galaxies. A galaxy is a huge mass of stars, nebulae, and interstellar material held together by gravity across unimaginable distances. The smallest galaxies contain about 100,000 stars. The largest contain up to 3,000 billion. There are an estimating 2 trillion galaxies within the observable universe, and that number keeps shifting as our telescopes improve. And astronomers sort every one of them by shape into 3 main families: elliptical, spiral, and irregular. On one side, ellipticals ranging from nearly circular to elongated ovals. On the other, spirals branching out by how tightly their arms wind. Elliptical galaxies are oval shape, dense concentrations of mostly old stars, with very little gas or dust left to form new ones. A textbook example is NGC 4486, a massive elliptical galaxy holding some of the oldest red giant stars known. NGC 4486, also called M87, became historic for a completely different reason in 2019. It was the very first black hole ever directly imaged, captured by the Event Horizon Telescope. A glowing ring of light bent around pure darkness, the first real photograph at last of exactly the kind of object we've been describing. Spiral galaxies look completely different, arms of gas, dust, and young stars spiraling outward from a central, bulging core. Our own Milky Way is one. So is the Sombrero Galaxy, named for its resemblance to a wide-brimmed hat. With a bright central bulge and a dark dust lane cutting across its disk. Surrounded by dense clusters of ancient stars, with less densely populated regions farther from its glowing core. In a barred spiral, those arms unwind not from a round core, but from a straight bar-shaped structure of stars slicing through the center. NGC 2997 is a beautiful example. You can see hot, ionized hydrogen gas glowing where new stars are actively forming inside its arms.
Every galaxy, no matter its shape, sits inside something invisible, a vast halo of dark matter, often stretching far beyond its visible stars.
Without it, the outer stars in a spiral galaxy would be moving too fast to stay gravitationally bound. The galaxy should fly apart, but it doesn't.
Irregular galaxies have no obvious shape at all, often the result of intense star formation or gravitational chaos from a nearby galaxy. The Large Magellanic Cloud is one of the closest examples, home to the Tarantula Nebula, one of the most active star-forming regions ever observed. The Large Magellanic Cloud is one of the closest examples, home to the Tarantula Nebula, one of the most active star-forming regions ever observed. NGC 5754 shows this happening in real time, a smaller galaxy colliding with a much larger spiral, its arms visibly warped by the encounter. NGC 5754 shows this happening in real time, a smaller galaxy colliding with a much larger spiral, its arms visibly warped by the encounter.
And this isn't just a distant curiosity. Our own Milky Way is on a collision course with the Andromeda Galaxy, roughly 4.5 billion years from now.
Our own Milky Way belongs to one such group, called the Local Group, alongside Andromeda and roughly 80 smaller galaxies. Now for the strangest objects in this entire story, quasars. The name stands for quasi-stellar radio source. Through early telescopes, they looked deceptively like single stars. They are, in reality, almost unimaginably distant and unimaginably bright, some of the most luminous single objects ever detected in the universe. For decades, their true nature was uncertain. Today, we understand quasars differently. As the blazing cores of young, active galaxies, powered by supermassive black holes devouring surrounding matter. The furthest known galaxies are around 12 billion light-years away. The furthest known quasars push past 13 billion. Meaning we're seeing them as they existed just a few 100 million years after the Big Bang itself. Meaning we're seeing them as they existed just a few 100 million years after the Big Bang itself. Some closer galaxies are almost as extreme. Astronomers call them active galaxies, in two main types, Seyfert galaxies and radio galaxies. In a radio galaxy, like Centaurus A, that radiation doesn't just come from the core. It also erupts outward in enormous lobes on either side, sometimes stretching far beyond the visible galaxy itself. Those lobes can be enormous, sometimes stretching millions of light-years from the galaxy itself, among the largest single structures ever found in the universe.
The quasar 3C273 shows this dramatically too, a jet of high-energy particles blasting outward from its nucleus, visible across vast distances in radio wavelengths. In every one of these cases, the source of that extraordinary energy is thought to be the same thing: matter falling into a supermassive black hole at the galaxy's center. In every one of these cases, the source of that extraordinary energy is thought to be the same thing: matter falling into a supermassive black hole at the galaxy's center.
Here's something your average textbook won't tell you. In recent years, the James Webb Space Telescope has found something surprising. Galaxies that are large, structured, and mature far earlier in the universe's history than older models predicted.
It's forcing astronomers to reconsider exactly how quickly galaxies were able to form and grow in the young universe, a genuinely open question being rewritten in real time.
So the next time you look at a single point of light in the night sky, remember, it might not be a star at all.
It could be an entire galaxy, 100 billion suns, or 3,000 billion.
Compressed by distance into a single point too small to see with your eyes alone. Every galaxy we've talked about today, spiral, elliptical, irregular, colliding, blazing with radiation, is a chapter in the same story we started with: matter organizing itself across billions of years into something structured enough to eventually understand itself. And somewhere inside one ordinary spiral arm, on one ordinary planet orbiting one ordinary star, that's exactly what's happening right now.